Hey Thinksters, what's up? It's Adam, and in today's video I'm going to be talking to you about how to draw excellent and professional looking line plots in Matplotlib. But very quickly, before we get started, if this type of content is what you're looking for and you enjoy it, please consider hitting that subscribe button below this video and turn notification bells on. We are putting out content every single week like this. We want you to become as good as you possibly can in not just Matplotlib, but all aspects of Python. So without further ado, let's get into it. So the line plot is the most iconic of all the plots. You've seen them all around the world throughout your entire life. To draw one in Matplotlib, really simple. You use the plt.plot function. So pass it a list of numbers and it will use them as the y-axis values, and it will use the list and indexes of the list for the x-axis. So for example, we're going to use a list comprehension here to create the square numbers from 0 to 10 inclusive, so x squared for x in range 11. We're going to save that as the list squared, and then we just pass that to plt.plot, call plt.show, and boom, this is what we get. You can see here nicely at 0, it's 0, and 10 squared gives us 100, and all the values in between are there. And you'll see also that it joins them up with a line. Wonderful, that is exactly what we wanted. Now, in this article, I'll show you how to add axis labels, plot multiple lines on one graph, and customize your plot expertly to showcase all your data. But first, a quick overview of line plots. So they're a bit like scatter plots in that they show the relationship between two variables, but unlike scatter plots, they're usually used to measure how a variable changes over time. So we'd use a line plot to show how the stock market has performed rather than a scatter plot, because a line just has that idea of kind of uniform and it's moving throughout time. Whereas a scatter plot, if you've seen our scatter plot article, check it out. Link will be in the description and throughout this article as well. A scatter plot can be used to plot things which don't necessarily have like a linear correlation or like a regular correlation. So for example, the total bill versus the tip is the example we use in the scatterplot article. Go and check that out. So line plots really good for time series data because we just put time on the x-axis and whatever we are measuring on the y-axis. So before we do any more plotting, let's first import the modules we'll be using. So of course, import matplotlib.pyplot as PLT. This is the standard import, and then numpy as well as MP, as we're going to be working with numpy arrays. And I like to do this at the top of all of my Matplotlib work. Use plt.style.use. So we're going to set the style to Seaborn. So the Seaborn style is characterized by this gray background and these nice grids, and then also just a nicer color scheme, really. I think it's much easier to understand and actually read off these values than it is on the default Matplotlib settings, but it's absolutely up to you, whatever you want. So let's dive into a classic example, the US stock market. So here we have the S&P 500 index, but for some reason I've written SP. There we go. The S&P 500 index over 2019 with the default settings. So this is, if you don't know what this is, it tracks the top 500 US stocks. So it's a reflection of the US stock market overall. And you can see for 2019, it's been great, really, for the most of the year. It's got a distinct upward trend. So really good year this year. You can download all the data for free here online at this link. I have split it into two different numpy arrays. So one for the S&P 500 values, so that one's SP 2019, and one for the dates, so that's called dates 2019. And we'll see one later using 2018 as well. And if you want to learn how to work with dates and times, check out the article I wrote here, linked there. The dates only include business days because the stock market is only open on business days. So here's a quick look at the code. So Biz 2019, first 5 days, you'll see we've got 2019 1-1, 2019 1-2. So this means the year 2019, the month is 1, and the day is 1. This is the first 5 business days. and then the first 5 S&P 500 values in 2019. You'll see that the first one is actually a NaN value, so that stands for not a number, and this is what NumPy and Pandas and lots of scientific packages use to represent missing values. So because there are some missing values in the data, the way Matplotlib will handle it, you can see, for example, here, is it just doesn't plot them. It doesn't cause any errors. It's okay, especially if they're NaNs. But it's good enough for our purposes. As you can see, we've got some missing bits, but you can still see the overall trend, which is what we're trying to do in this article. So, like the first example with squared numbers, to plot it, really simple, just plt.plot, and then SP2019 in there, plt.show, and this is what you get out. So, what does this actually give us? So it shows us the S&P 500 values on the y-axis, but the x-axis doesn't have any dates. It has the numbers 0 to 250, so where have they come from? So if you only pass a list or NumPy array to plt.plot, the way it, obviously every graph has an x and y-axis, so it will plot the values you give it, as I've already said, on the y-axis, and then the indexes of this list on the x-axis. And you see here, len SP 2019 is 250. So that's why it goes from 0 to 250. But obviously, it would be better if we had the dates on the x-axis. So to do this, we are going to pass 2 arguments to plt.plot. So first, as with all plotting functions in Matplotlib, it goes x-axis first, and then y-axis. So plt.plot, we're going to plot the dates on the x-axis, and then the S&P 500 values on the y-axis. And now you see, this is what we get. So we've got the values here, and the dates nicely here. And Matplotlib is great. It spaces the dates out evenly, and chooses a nice level of accuracy. So it's not done like January, February, March, all of them. It's just picked 7. It's picked 7 dates, and it's just chosen the months as well. It hasn't gone down to like the day level, or it hasn't randomly picked like the 13th of January and then the 28th of February. Like it's worked through them nicely, and this is just the automatic settings, and it works pretty well. So the last thing we need to do for this plot is to add some axis labels and a title, because although we know what these things mean, if you looked at this for the first time, or even in a few weeks, you might forget exactly what it is. So the way to do this is 3 really easy functions: plt.title, plt.xlabel, and plt.ylabel. Each of these take a string. So here we're going to call this the S&P 500 index 2019. Then on the x-axis, we're going to put the date, and on the y-axis, we're going to put index. And you just put this in between your plt.plot call and plt.show. And then this is what we get. And there we go, perfect graph. Just a heads up though, I'm going to exclude the lines of code that set like the title, X label, and Y label, just to save space for the code coming through. But obviously make sure to include them in your plots, and you'll see all of the plots and images in the rest of this article do have everything labeled, so don't worry about that. So let's move on to changing the color of your plot. So this is a super important part of plotting, and really deserves an entire article in itself. When I was first learning about this, I felt that the Seaborn docs linked here were a really great overview, and I didn't realize the impact that color could have. So it really can make or break your plot. Some color schemes, especially if you're dealing with large amounts of data, using things like heat maps, or even just lots of different lines on one plot, can make it really hard to understand what's going on, and some of them make it super easy. So really important. I would recommend checking out these docs, and there's even some papers on there as well if you're even more interested. But one reason to change the color is just for aesthetic reasons. You might not really like this blue color, you might want red or black or something else. So to do that, very easy. You use the keyword C or color, spelled the American way, and the default setting is blue. So you can choose any color you want. So you can use an RGB or RGBA tuple. So that stands for red, green, blue, and alpha. So each of these elements in the tuple is a float in the range 0 to 1. Or you can pass a hex RGB or RGBA string. such as this. And these all represent different colors, and you can pick literally anything you want. But most of the time, you'll just use one of the 50 plus built-in named colors. And the most common are, as you would expect, blue, red, green, black, white. And really easy to remember these. All of them are just the first letter like you would expect, apart from black, which is K, because black ends in a K, and you can't have two starting with blue, because that's already taken. You can't have two starting with B, that's already taken with blue. So here is the S&P 500 index for 2019 plotted using all different colors. So you can literally use whichever one you feel comfortable with, whichever one you think is best. There is definitely an art to plotting, so really the choice is up to you. And the way to do this is in your plt.plot call. You're going to pass our x-axis values, we're going to pass our y-axis values, and then we're going to set color equals, and then the string representing the color we want. So this one, color equals B, is the default, color equals R is the red, and we can also use C instead if we just want to be a bit quicker, and then that sets it to green and black respectively. And of course, you can use C equals R, or C equals B, or color equals G. It doesn't matter. Just wanted to show you the options. Okay, now let's plot multiple lines on one Matplotlib plot. Gosh, a bit tricky to say. So if you draw multiple plots at once, Matplotlib automatically colors them differently. So this makes our lives really easy to recognize the different data sets. So we're now going to plot the S&P 500 index for 2018 and 2019 on one plot. So this allows us to compare how it performed month by month, and we can see, oh, it was better in 2018 here or better in 2019 here. And the way you do this is you just make multiple plt.plot calls before calling plt.show. So every time you call plt.show, it will make a new plot, basically, with everything that you've given it beforehand. So here we just do plt.plot, SB 2019, and then SB 2018. Then we call plt.show, and this is what we get. So I have labeled the axes here, of course, and it looks great, right? Really easy to tell the orange and blue lines apart, but we do have a couple of problems. So first one, the date axis doesn't show dates. And second one, we don't know which line is which one is 2019, which one is 2018. So let's solve the first problem first. The way to change these axis labels is so this plot looks exactly as we hoped, right? The only thing we want to change is that these axis labels say something differently. So the way to access these guys is that, well, in Matplotlib, they're called xticks. So we use the plt.xticks function, and it has two arguments. So it accepts the ticks and the labels. So the ticks are the positions on the x-axis to place the ticks. So here this would be position 0, position 50, 100. And these do correspond to like mathematical numbers. And then the labels are a list of labels to describe each tick. So in this case, we want them to be the months of the year, but we could pass any string we want to label them. And if you don't pass any labels, it will automatically just use the tick values. So in this case, the ticks are the numbers 0 to 250 inclusive with a step size of 50. And then the labels will just be months of the year to make it simple. So we're going to do plt.plot SB 2019, 2018. Then we're going to create our ticks and labels. We'll just do it manually here. We could do it in some other ways, potentially using MPA range if you wanted to. But it's pretty easy to understand this, so let's go with this. And then all we do before we call plt.show is do plt.xticks and pass ticks labels. And then here we go. So now we've got January, March, May, July, September, and November marked on the date axis. We've got a title that tells us what we want, what this is about, and we've got the index values here. The only thing missing still is we don't know which line is which. So let's add a legend. To add a legend, we use the plt.legend function. This is really easy to use with line plots. All we have to do is in each plt.plot call, we're going to label each line with the label keyword. So when you call plt.legend right at the bottom, Matplotlib draws a legend and it has an entry for each line. So we're going to update our code here. It's the exact same as above, but in our plt.plot call, first we've got SP2019, and then we use the label keyword, and we pass the string that we want our legend to say. This is obviously the 2019 data, and we're going to do the same thing for 2018 data, label it with 2018. Then we call plt.legend, and we still need to update our xticks like we did from before, so this is just the same code. I've skipped out this bit just to save space. Then we call plt.show, and boom, there we have it. We now have a nice little legend here in the top left, not obstructing any of the data, and we can see that the blue line is for 2019 and the orange line is for 2018. So now we know that like 2019 was better in almost every single month than 2018. So by default, Matplotlib draws the legend in the best location. This one looks pretty nice to me. But you can manually set the location as well in the plt.legend call using the lock keyword, standing for location. So there are 10 self-explanatory strings that you can use. So they are upper right, upper left, upper center, or lower right, left, and center right or center left, and then right or center. But for some reason, you can't put it left. That isn't an option. Not sure why. There you go. So here's an example of putting the legend in different locations. So here we're going to put, so in our plt.legend call, we did the exact same code, but just put lock equals lower left, and now it's down here. And it's best practice to put your legend somewhere where it doesn't obstruct the plot. But if it does obstruct the plot, Matplotlib isn't going to stop you. You could put it in the center here, and it would appear over all the data, and that's of course your choice, whatever you want to do. So this one is plt.legend lock equals upper center. Fantastic. So that's how you work with legends. Let's now move on to line styles. So you may think that this solid line is nice, but you want to mix it up a bit. You want to try something else. Can we do it in a different way? Could we do a dotted line, for example? Yes, we can. So we set them with the line style, or ls, obviously standing for line style keyword in our plt.plot call. Syntax, really intuitive, pretty easy to remember. Here are the 4 line styles that are possible with the square numbers from 0 to 10. So first one is solid. And that is with the hash, the hyphen string. Next one is dashed. So you can see here these dash lines, and that's 2 hyphens. Next one is dash dot. You'll see there's a dash and a dot, and the string for that is a dash or hyphen and a dot. And then finally, dotted, and that is you pass a colon. I think all of them match the output quite nicely. Matplotlib does a really nice job of this, I think. So, and here it is as the code, so plt.plot. So we're going to pass our squared list again. Remember, that's our numbers from 0 to 10 inclusive squared. And then we set the line style with the line style equals, and then here we go, hyphen or double hyphen, dot, dash dot, or colon. And you can also actually pass the line style names themselves instead of this short form of the string if you want to be a bit more explicit. So these are the names. So solid, dashed, dash dot, or dotted, again, makes a lot of sense. And I think is what you would reach for in your head if you're trying to describe it. So again, quite nice and easy to remember. Another thing you might want to change about your plots is the line thickness. So you can set this to any float value you want by passing it to the line width, or LW, standing for line width keyword, in plt.plot. So here is the same plot of our squared values, just with a solid line this time with varying line width. And a smaller number means a thinner line, so bigger number means thicker line. Pardon me. So here we've got plt.plot squared line width equals 1. Got that there. 3.25 here, 10 here, and 15.35 here. Play around with this, see what you think fits best for your plot. It really is up to you to decide how thick you want your lines. And then line width is the exact same as line thickness. So to do that, this is basically just a repeat of this. So we'll quickly move over that. Let's move on now to Matplotlib line plot with markers. So at the moment, these are just lines. There's no, we can't tell on these plots how many points we've got. We could have the square value for every single number, like 0, 0.1, 0.2, 0.3, 0.4, 0.5, all the way up to 10. Or we could just have like 0, 5, and 10. You can't really tell. So one way to show the actual data on top of the line plot is to add a marker to your plt.plot call. So that is highlighted with the marker keyword. There are over 30 built-in markers to choose from, and you can use any LaTeX expression, and you can even define your own shapes. So loads of customization possible, but we'll just cover the most common ones. And like most things in Matplotlib, the syntax is really intuitive. So either the shape of the string reflects the shape of the marker, or the string is a single letter that matches the first letter of the shape. So we've got an O, which looks like a circle, so that's a circular marker. We've got the caret symbol for a triangle up, which looks like a triangle going up. We've got S for a square, plus symbol for plus, capital D for diamond, and then if you want to use LaTeX syntax, you use the same syntax as you would if you were writing a LaTeX document yourself. So for example, starts with and ends with the $sign. So for example, if you did /pi in between two $signs, it makes each marker the Greek letter pi. So let's have a look at some examples. Here we go. So this is circle O, and you'll see that this is like a scatter plot. If we do plus, then you've got the plus symbol, diamond, basically a sideways square, and triangle up like this. And again, it's up to you to decide which one you think looks best and which one you would prefer to add to your plot. And to do this, very similar to the other things we've been doing, so plt.plot squared, you just put marker equals small o to get circles up here, plus to get the plus, and so on. Unfortunately, there is no shortcut for this. If you want to set marker, you have to write marker equals. There's no like m equals. And as a note, if you set line style equals the empty string, you won't plot a line, you'll just plot the markers. So this is what it looks like here. So without any line drawn. So we've got plt.plot squared, marker equals circle, and then line style equals the empty string. So if you want to plot something that looks a bit more like a scatter plot, or you just think it looks better without a line, then feel free to do that. This works obviously quite well if you have lots and lots of points, and then they can so even though there is no line joining them, it's still possible to see the relationship between them. Yeah, but it's just something you can play around with in your data analysis and see whether it looks better. And then final topic we'll be covering are format strings. So since setting the marker, the line style, and the color of a plot is something you want to do all the time, Matplotlib included a really nice and quick way to do it. So you can do plt.plot, and then you pass your y-axis values, and then the format string, or short FMT for short. Or if you do it with x-axis values, then plt.plot x-axis, x list, y list, and then the format string. So the format string is made up of 3 parts. So the marker, the line, and the color. So really like the line style and the color. And these square brackets mean that each of them is optional. So, and also you can pass them in any order you want. You don't have to do it in this order. And what you do is but you always have to pass the short version of the markers that we've covered. So you can't write black for the color, you have to write K. And likewise for a marker, if you wanted, well actually with markers you always use the short form, but with line styles you have to do like a hyphen. If you want a solid line, you can't write solid. That's the only restriction. So for example, O-G is circular markers, dash line, and a green color. And note that these are all equivalent. So plt.plot XY, and then this is the circle -G, But then you can also set it to marker equals circle, line style is dash dash, color is G, and then you could even shorten this further with marker is circle, ls is dash dash, c is G, and you could even change these around to do ls equals dashed, c is green, for example, as well. So there's lots of ways to write it. Really just pick whichever you prefer. I would recommend when you're starting out to be as verbose as possible, and just so that you remember it. But once you get comfortable with it, you will definitely see out in the wild an ls or a c, so it's good to know the short versions as well. So here's some examples of our lovely square numbers from 0 to 10 with different markers, line styles, and colors. So here we go. The top left is circles with a dashed line and red color. So that would be, and you can see down here how it's written, plt.plot squared, circle dash dash r. And then this one up here is a plus marker, dash dot line, which is hard to make out. Let's see, can we zoom in? Yeah, you can see here that it's a dash and then a dot. I think the dash dot line doesn't work that well if you have a marker. Kind of defeats the purpose of it, but you know, whatever takes your fancy. And then we've got one here, diamonds, solid line, and black. So this works very nicely together. So capital D dash K, and then a triangle up, a dot line, and blue. So you can see here that these ones don't really go very nicely together, I don't think. Likewise, like the plus one doesn't really work too well because the line doesn't go exactly through the center of the shape. For example, like these triangles here are off the line, and I actually think this can look a bit confusing because it's hard to see, like, where is the actual point that we're highlighting here. So just be aware of that and note that, you know, you can play around with it and see what works for you. Final thing to note is that if you don't specify a line style, so like dashed, dash dot, dotted, whatever, Matplotlib won't draw a line. So therefore your plots will look similar to scatter plots, like this. So these are just like circles red, and then the format string is just, oh, whoops, I haven't updated this. Right, I need to update this. But the title should say 0R in the article, it will say that. And likewise, this is going to be DK without a dash. This is B triangle here. Yeah, so this one's been updated. And then plus G, and then again, without this dash bit in the middle, is what it looks like. And for this reason, some people prefer to use plt.plot rather than plt.scatter, even when they're plotting scatter plots. So they just always make sure to specify this without any dash lines, and then you get basically a scatter plot, but you can just use the same functionality over and over again, so you don't have to use the scatter plot functionality if you don't want to. So there you go. You now know all the essentials to make professional looking and effective line plots. So you can change the color and plot multiple lines on top of each other. You can write custom labels for your axes and title. You can also clearly explain the different lines using a legend, and you can customize the look of your plot using color, line width, markers, and line styles. Whew, that's a lot. Where should you go next? Well, if you want to earn more money, if you're in a dead-end 9-to-5 job, if you dream of breaking free and coding full-time, maybe you want to be a data scientist like myself, but you're not sure how to get started, then I empathize with you. I understand you. Like, becoming a full-time coder is really scary. There's so much coding info out there that it's really overwhelming. I felt that when I was first starting. And also, most tutorials are teaching you Python, they're teaching you data science, web development, whatever, and then they tell you to get a full-time job again. But why would you want another office job? Don't you crave freedom? Don't you want to travel the world? Don't you want to spend more time with your friends and family? Like, there are hardly any tutorials out there that teach you Python and how to be your own boss, and there are literally none that teach you those things and how to make 6 figures a year. Well, until now. I'm a full-time Python freelancer. I just work 4 hours a day. I live anywhere in the world that I want. I'm currently in Warsaw, Poland, as I'm recording this. I set my own schedule, set my own hourly rate. My calendar is booked out months in advance, and I've got a constant flow of new clients. Does that sound good? Sounds a bit too good to be true, right? But it's not. I want to show you the exact steps that I used to get here. I want to give you a life of freedom like the one I've had and the one I've got now, and I want you to be a 6-figure coder like me. So if this is of interest to you, please do click on the link below and watch the Pure Value webinar. So it's not me in it, it's my colleague Chris, and he's going to show you, he's the exact same as me, he's going to show you the exact steps you need to take you from where you are, regardless of your level of Python, to a full-time Python freelancer. So these are proven, no BS methods, and they're going to get you results fast. Click on this link below, it will take you to this webpage. This is Chris right here. And you can watch the free webinar replay. It's just packed full of value, showing you the step-by-step things you need to do to become a full-time Python freelancer and make $3K a month working only 4 hours a day. And from there, the sky's the limit. You can make 5K, 7K, 10K, 15K, 20K a month. Doesn't matter if you're a novice, doesn't matter if you're a pro. If you aren't making 6 figures a year right now with Python, you will 100% learn something from this webinar. I've met loads of people who are great at Python and they still feel stuck in a job because they don't know how to get clients on Upwork, they don't know how to get freelancing gigs. And this is what this webinar is going to teach you. But I've got to say, it won't be online forever, and the seats will fill up. So click the link below right now before they fill up so that you can learn how to become a Python freelancer and live a life of freedom. Thank you so much for watching. I hope you click on the link. If you have any questions, ask in the comments below. Post on the article. We always love to hear your feedback. We'll be coming at you with way more content like this to take you from a Python novice to a freelancer and 6-figure coder. Best of luck and see you soon.